Okay, we have a new thing we're going to look at today. That's this with the percent yield, but I did want to make sure that on this example here, on this example 13, that we understand the final answers here. Just want to make sure we know what's going on. So you have two answers. You have the how much chemical is made or produced, and that's the 4.77 grams of H2S. And the other piece to the puzzle is you have one of your chemicals is called a limiting chemical, and that was the HCl. The reason that's limiting is because it ran out. We used up all the hydrochloric acid to get the 4.77 grams. Okay, so that's your chocolate chips. We ran out of those. So these are the cookies. And then the other thing is that there's an excess chemical, and that's the one you had more than you needed. So we had 13.2 grams of the iron 2 sulfide, and we didn't need all of that. We only used part of it. So we call that the excess chemical. And then down here, you do all this math and you come up with, okay, I started with my 13.2, but then I used up 12.3. So how much I started with minus how much I used up is how much is left over. And so at the end of the day, in the bottom of the container, you had 0.9 grams floating around, and they did not react. So just thought we'd go over that real quick. Let's jump over here to the next one, which is it's a new concept, and I would doubt that you had it last year, and so I think sometimes maybe we do a little bit of with this in some early labs in our chemistry, our 10th grade chemistry courses, but we have this term percentage yield, and you can think of it as also percent yield. That's normally how we refer to it here in the classroom. And so what this really is this is a measure of how well you did in the lab, success in the lab. So let's say that you are in the lab and you are creating some wonderful crystals, and you separate your crystals out and you have a stack of them, and you measure out those crystals, and you find out that the crystals weigh, we'll call it 8 grams. All right, so your crystals weigh 8 grams. And then as part of one of your lab questions, the lab is going to ask you for percent yield. So you find out from your instructor or from the lab or from research that you're supposed to get 10 grams. So you got 8, you're supposed to get 10. So it's a very simple percentage. If I got 8 and I was supposed to get 10, I can just take 8 divided by 10, which is simply what I got in the lab on top versus what I was supposed to get on bottom times 100, and that would be an 80% yield. And that's okay, not bad. All right, so we have some terms here to make sure we kind of understand. And so that first term is percent. The first term is percent. Oh, sorry, theoretical yield. And so it's used to find percent yield. So the theoretical yield here is how much you were supposed to get. So this is a what I usually call a pencil or a pencil and paper value, meaning you calculate it. So it's a pencil and paper value. And it's the maximum. Well, that's a terrible U. It is the maximum amount of chemical that you could get in a reaction. So it's a pencil and paper value. It's not real. It's not from the lab, and it's also the maximum. It's the maximum amount of chemical that you could create. So let's go back up to our first example here. And so if we're doing our example that I just sort of made up here up there, and you went into the lab and you got 11 grams, well, that doesn't make any sense because the theoretical, which is right there on bottom, is 10. 10 is the max. And so if you get 11, well, that doesn't make a lot of sense. So what happened is if you get more than you were supposed to, then you had some impurities. You did not get the reaction to go like you wanted it. And so this pencil and paper value is going to end up being that value, that value we're dividing by. That's the denominator. And so that's something that maybe you can kind of draw a little arrow there and kind of help yourself out. So it's a maximum value. I think that's really important, that you can't get more than that unless you have impurities, which it's not really the chemical, right? It's other stuff. Okay, so then there's B, which is the actual yield or the experimental yield. And this is a real value. This is a real measured value, meaning you measure it in the lab. This is a real measured value. And I think it's good to think of this as a lab value. So this is something that we would find from the lab, okay? And so then percent yield is pretty straightforward. To get the percent yield, you take your actual or your value from the lab, and then you divide it by your theoretical, which was that calculation or that pencil and paper value. And then you get a percentage. And so think of all the problems we've been working and the stoichiometry and stuff. And so basically, if you have a reaction, and we can just make one up, if you have hydrogen and oxygen, and we're making some water, very simple reaction there. If we're doing that and then we go ahead and balance it, well, we can do math and we can figure out how much water you would get. Like, let's say you had 2 grams of hydrogen. Well, we can figure out how much water you're supposed to make just by doing the stoichiometry. All right. So once we do that, that becomes the theoretical value, right? So we're going to do the math and we're going to get the theoretical value. Now, if we want to see how this works in real life, well, we then are going to go ahead and do this in the lab, and we're going to measure the water we collect, and then that's going to go up here in the actual. So the actual is going to be the lab value, and then that theoretical, we're going to get that by doing some stoichiometry, right? So I think that might kind of help you out. So I know I kind of wrote all over this, but this is kind of what I'm hoping you guys do when you're doing your work, is that you're making a lot of notes to yourself, things that make sense to you. And obviously you can go back and clean things up. I mean, this is a little bit messy, and you don't have to have my example, but like the idea is that with any of these chemistry problems, we can do the math and come up with that stoichiometry, which is going to give us that number on bottom. Last little thing maybe on this one is that it's really, and this is very simplified, but it's really, you need to make sure that your smaller value is on top and your larger value is on bottom. Because if these are inverted, if the large is on top and the small is on bottom, you're going to get percentages over 100%. right? And so that's not what we want. We don't want percentages over 100%. So you might want to write down, just kind of as a final thing, that percent yield should not be over 100%. Unless, of course, there is an impurity. So, if it is, then either your math is wrong, so the math is bad, or the reaction is bad, or you have extra chemicals or impurities in your sample. This actually happens in the chemistry lab quite a bit, where you do the lab and it doesn't all react, and so there's pieces in there that you were not expecting, and they're going to throw off your percent yield. But I think this is kind of a good thing to remember, that the percent yield should normally not be over 100%. So okay, so went through a couple things here. I'm going to probably hold this video at this point just to make sure we get under that time frame.